Right, hello viewers, we are going to look at center of gravity, and under center of gravity we are going to consider unsymmetrical section. It is called unsymmetrical section because this is the y and this is the x, this is the y and this is the x-axis. We have like this is y and this is x-axis. It is called unsymmetrical because if you divide this shape at this point, at the center, you will not have the same thing here and the same thing here. And if you also divide it in this half, like this, okay, let me say the first one, you divide it this way, down, you will not have the same shape here, and by the right and by the left. And if you also decide to divide it at the middle into this half, you are not going to have the same shape at the top and at the bottom. So when you have a situation of this nature, you say that the shape is unsymmetrical in nature. So because the shape is actually unsymmetrical in nature, we are going to find both the centroid in the y-axis and the centroid in the x-axis. And so we've been given this. The length here is 16 cm. We have the breadth here to be 4 cm, and we have another 4 cm here, and we are told that from here to here is 12 cm. So this is L section. So the first step is for us to divide this shape into two. We have the first one here and 2 here, and so that's what we've gotten here in this step 1. So in this step 1, this is the first shape. So you take it, you cut it out here, like sectioning, you cut it out here, and so we have this 16 down and 4 down, we cut it out. So we have this other shape, which is shape 1. And then our shape 2 is from here down, we cut it out from here down, and so that gives us a shape 2. But note that we've been told that from here to here, from this point to this point, is 12 cm, but we know that from here to here is 4. So when you subtract 4 from here to here, it means from here to here will now be 8 cm. So that's why we have from here to here to be 8 cm, which is actually from here to this point. And so we've been able to section the shape into 2, 1 and 2. So the second step is to find the area of these different shapes. And so we have for shape 1, which is rectangle. This is a rectangular shape. This is also a rectangular shape. So for rectangle 1, we are taking this one into consideration. Now we have that the area is length times breadth. This is the length and this is the breadth. So when you say 16 is the length, the breadth is 4 cm. So when you say 16 times 4, that will give you 64 cm. And then for us to find the x, the centroid of this particular shape in the x-axis, note I said this is the x-axis, so any line going towards this direction is the x, and any line going towards this direction is the y-axis. And so for this shape, okay, for this shape, our x is 4. And so for you to find 4, the rule is you say x1 will be x divided by 2. That is, the shape here going this way is 4. The line is 4 cm divided by 2. So that's why we have x1 to be 4 divided by 2, and that will give us 2 cm. And now for y is, for rectangle 1, we are still with rectangle 1. So y is this line down. So it is 16. So we divide 16 by 2, and that will give us 8 cm. So we are done with rectangle 1. So we go to rectangle 2. So in rectangle 2, we are going to do the same thing. We find the area, which is length times breadth. This is the length and this is the breadth. And so we are done in finding the area, which is 8 times 4, that will give us 32 cm squared. And so we have to find x2 because we are dealing with the second rectangle, which is 2, rectangle 2. So we have here to be, from here to here is 8 cm, which is the same thing as from here to this point, But note that what we took was from here to here, but there is another shape that is from here to here, which is 4 cm. And so that's why we are having 4, which is the first one from here to here, plus from here to here divided by 2. So we have 4 plus 8 divided by 2. I want to explain that again. When we are considering the second rectangle, coming back to here, we understood that from here to here is 12, but the second rectangle from here to here will be 8. And so when we are finding the x-axis, because we are going to consider everything from here to this point, since these two are actually joined together at this point. So the first one we'll take from here to here, which is 4, plus from here to here, which is another x, divided by what? 2. And so that will give us 4 plus 4, which is equal to 8. And for our y is very simple. It's just from here to here, because this actually did not cover up to this point, so we wouldn't consider the length from here to here. It's just from here to here, 4. That is from here to here, so we divide it by 2, and then that will give us 2 cm. And then for our step 3, we say that let the location of the centroid in the x axis be x bar, and in the y axis be y bar. So this is the formula for calculating centroid in the x axis, that is in this axis. So we have the area a1 times x1, we've calculated x1, plus a2 times x2 divided by the area 1 plus area 2. So from our calculation, we have that our a1 is 64. So we have it here, times our x1. Where is our x1? x1 is 2, so we have times 2 plus a2. Our a2 is 32 cm squared, times our x2. Where is our x2? 8 cm. And so we divide it by the first area, area 1, which is 64, and then area 2, which is 32. And so when we do this, this times this will give us 128, plus this times this will give us 256, divided by this plus this, that will be 96. And so when you add this, you have 384 divided by 96, which will give you 4 cm. So what this implies is that the centroid in x-axis will be 4 cm. And then we do the same thing to the y-axis. a1 times y1 plus a2 times y2 divided by a1 plus a2. And then we know what our a1 is, 64, times our y1, which is 8 cm, plus a2, where is our a2, 32 cm, and our y2, which is what, 2 cm. And so we divide it by area 1 plus area 2. And so when we do that mathematics, our answer is going to be 6 cm. So basically, this is how to find the centroid of a shape when it is unsymmetrical. Okay, so if it is unsymmetrical, it means you have to find for the x and the centroid in the x-axis and the centroid in the y-axis. Thank you.